Let me start this off by saying that the math that you're actually going to be doing here is not going to be too tough. It'll be pretty straightforward. The more important thing is to understand the concept that we're going over here. What we're going over today is the rational zero test. That's generally what it's called. You could also hear it be rational root. Remember, x-intercept, roots, zeros, they all effectively are just different terms that mean the same thing. I have most often heard it called the rational zero test. What the rational zero test is, as it says here on the screen, if a function has integer coefficients, then every rational zero will be in the form of the factor of the constant term, which we refer to with p, divided by a factor of the leading coefficient, q. So, first off, whenever it says a function has integer coefficients, remember that integer just means a whole number, meaning no fractions, no decimals in front of the variables, but they can be positive or negative. When it says a rational zero, remember rational means that you can express it as a fraction. Okay? So what it's saying is if you have a function that has only whole number coefficients, you don't have any fractions or decimals in front of the coefficients, not necessarily every zero of the function, but every one that can be written in a fraction, you can find them by taking the factor of the constant term. Remember, a constant is a number without a variable, divided by factors of your leading coefficient. Remember, leading coefficient would be the coefficient, the number in front of the variable specifically, with the greatest, the highest exponent. Okay? Now the idea here, because all of that sounds like a lot of work, but it's really not that. It's really not that complicated. The important thing to understand, though, is this is not a test, this is not a formula that tells you exactly what your zeros are. It does not tell you exactly what the x-intercepts are. What you're doing is you are creating a list of possible zeros for your function. And within that list, you can feel confident that one of the numbers on your list is going to be one of the zeros of the function. Now, if you want to know for sure which one it is, there's a whole lot of extra work that needs to be done with this, or you have to go to a graphing calculator or something like that. All we're going to talk about today is how to list out how to make a list of possible zeros for your function. Okay? But, like it says, the way we do that is we take factors of your constant term divided by factors of your leading coefficient. So, for example, if you take this function down here, f of x equals 2x to the third plus 5x squared minus 27x plus 12. First question to ask yourself is what is the constant term, what is the p value of your function? Well, in this case, that would be 12. Right? 12 is the term that we have there that has no variables with it. Your next question to ask yourself would be what term would represent your leading coefficient, your q value. In the case of this function, the variable that I see with the greatest exponent would be this x to the third. Its coefficient is 2, so that would make 2 our leading coefficient. So 12 is our p, 12 represents p, 2 represents q. So in that case then, what we want to do is we want to make ourselves a list here. First, we want to list out all the factors of p. We want to list out all the factors of p, so all the factors of 12. Now when we list out these factors, I guess actually I should remember when we say factors, we're talking about numbers that 12 divides evenly by. So any number that 12 divides evenly by is a factor, okay? When we write out these factors, we want to consider both the positive and negative versions of every factor. Because if you think about factors of 12, let's deal with the most obvious factors. Certainly 1 times 12 would give us 12, right? 12 divides by 1 and divides by itself perfectly. 1 times 12, the pair of 1 and 12 as factors, does multiply back to positive 12. But also, negative 1 times negative 12 would still give us positive 12, because a negative times a negative is a positive. So when we're listing out these factors, we could always make it work for the positive or negative version. So we're simply going to put a plus or minus sign with every single factor. We will go ahead and start with 1. I want to make this list from least to greatest as best I can, so we'll start with 1. So then we ask ourselves, does 12 divide by 2 evenly? Well, yes, it does. So we'll put a plus or minus with the 2 as well. Then we want to ask ourselves, does 12 divide by 3 evenly? Yes, it does divide by 3 evenly. So we'll put a plus or minus there with the 3 and list that as a factor. Then we ask ourselves, does 12 divide by 4 evenly? Yes, it does. So we have another number to add to our list. Does 12 divide by 5 evenly? No, it does not, so we won't add that to our list of factors. Does 12 divide by 6 evenly? Yes, it does. 12 does not divide by 7, 8, 9, 10, or 11, but it does divide by itself evenly, so we'll finish out our list with 12. Right, and notice how we've written out the pairs, right? 1 and 12 are pairs, 2 and 6 are pairs, 3 and 4 are pairs. They each pair up to multiply back to 12. For our next list, we want to list out our factors of q. Q representing our leading coefficient. Well, our leading coefficient is simply 2, so this list is going to be much shorter. Everything divides by 1, so certainly 1 is always going to be in your list of factors. Besides that, 2 will also divide by itself, but that's it, right? You can't go higher, you can't find factors that are higher than the original number itself. So that's all I have for factors of q. Now, neither of these is the final list we want. These are the two lists we make so that we can make our list of possible rational zeros. And that's how I'm going to label this. Possible rational zeros. Now, the way to actually find our list of possible rational zeros is exactly what the definition that we talked about earlier tells us. The earlier definition said we were supposed to take factors of p, factors of our constant, and divide it by factors of q, factors of our leading coefficient. Meaning, for our list of possible rational zeros, what we want to do is take p divided by q. And that is every single p divided by every single q. Meaning, the way I like to do it is I like to start with a factor of p and I just divide it by every q factor. Meaning we'll start with 1. So if I take 1 divided by my first factor of q, that would be 1 divided by 1. Well, that's just 1. Then I can take my factor of p, my first factor of p, 1, and divide it by my second factor of q, which would be 2. 1 divided by 2 is 1/2. I am now done with that factor of p. I've taken care of it. So now I move on to the next one. 2. I'm going to take that factor of p and divide it by both 1 and 2, both of the factors of q. 2 divided by 1 is 2. So we'll add that to our list. Get a better comma there. And then 2 divided by 2 gives us 1. Well, we already have 1 right here in our list, so I don't need to repeat that. I just get to move on, so I'm done with this. Now I move on to 3. I'm going to take 3 divided by both of the factors of q. 3 divided by 1 is 3. 3 divided by 2, well, it doesn't come out evenly, so we'll just write it as 3/2. Now that I'm done with 3, I'll move on to 4. 4 divided by 1 is 4. 4 divided by 2 is 2. And we've already written that, so I don't need to write that part. Done with 4. Now I'll take 6 divided by my two factors of q. 6 divided by 1 is 6. 6 divided by 2 is 3. And once again, we already have 3 in our list, so I don't need to rewrite it. Which leaves us with 12, our final factor of p. So we take 12, divide it by our first factor of q in 1. 12 divided by 1 is 12. 12 divided by our second factor of q, 2. 12 divided by 2 is 6. We already have 6 in our list. So what we have done now is this right here is our full list of all our possible rational zeros. Now, if you were to actually graph out the original function, if you were to actually take this original function of 2x to the third plus 5x squared minus 27x plus 12, if you graphed that out, obviously you are not going to see it cross the x-axis as many times as we have possible rational zeros. It can only have 3 possible zeros in the end because that's the degree of the function. And we don't even know if it has 3 real zeros. It could have imaginary ones or something like that. What we can say for sure is that if we take a look at this full list of zeros right here, possible rational zeros, somewhere in that list, at least one of those represents a zero of this function. Now, if we wanted to find out which one for sure, we'd have to graph it ourselves or do some tests or something like that. But we have at least created a list that we can base off of, which, compared to where we started, which was literally any number we could come up with as a possibility, this is a much smaller list than that. That's the idea of what you can use the P's and Q's, the rational zero test, for.